Okay, arcs. Right, if we read the question here, it says OA is 50, 80, sorry. The angle there is 60 degrees. Calculate the area enclosed. And of course, area here is to do with the circle. So we know it's to do with pi r squared. But of course, it's not the full circle, it's only a fraction of the circle. The fraction is 60 over 360 in this case, because it's 60 degrees out of the total, times pi r squared. So it's just a case of putting the numbers in. Okay, and the radius was 80, wasn't it? So you work that out. Okay. Part B, what's the total length of the rope that is used to mark the landing area? So total length, we need this arc here. Of course, the full circumference is pi d. We want the fraction of it. So that would be diameter, of course, will be 160. That comes out to be 83.7. Don't forget, even though we just want this arc here, we just worked it out, we also need this as well because the rope goes around the whole thing. So don't forget to add on 280s. Okay. Meters, of course. Okay, so we added on the two lengths there. Okay, so next one, calculate the length of the perimeter of this logo. So we know the radius is 3. Okay. Because we've got quite a large sector here, it would be useful to work out this larger angle. Obviously that's 310 degrees. Okay. And then because we're working out the circumference part of it, the fraction will be 310 out of 360 times then pi d, so times 3.14 times the diameter, which is 6. So you get 16.2. Okay. The perimeter then will be the 16.2, but don't forget to add on the 2 lots of 3. Okay, so you get your answer there. Right, there is a part B to this question. A solid metal block is made as part of a machine that prints the logo onto the company's products. The part is made from a solid metal cylinder of radius 2 and height 6 as shown. So the radius here is 2, the height is 6. Calculate the volume of the metal that's been cut out. Okay. So if we think of that as a sector down here of radius 2, if we can work out the area of that sector, then we can just times it by the height, which is 6. Okay, so area of the sector area of a circle, fraction of a circle. Okay, so that's what we're looking for. Okay, so the answer comes out to be 1.74. Okay, and then of course you need to times it by that height. So volume times it by 6. You get 10.47 to 2 decimal places. Okay, so the next one says calculate the size of the reflex angle AOB. So reflex obviously is the larger angle there, reflex to the nearest degree. Now we've got to work out the angle, right? So it's a working backwards one. If you've got to work out the angle, so we call it x. Should we call it x? And then the fraction of the circle then we're talking about is x out of 360. And we're timesing it by now. Well, we've got to decide whether it's the area formula or the circumference formula. And if you look here, it says the length of the arc AB, so it's the circumference formula. Okay, ID. Of course, that comes to 66. So it'll be x over 360 times 3.14 times the diameter. Now, the radius 18, is it? Yeah. Okay, radius is 18. So the diameter is 36. 66. And what I would do next is work that out on my calculator. 3.14 times 36. Okay, and then divide that by 360. So you get 0.314 x equals 66. And then quite simply then x is easy peasy. Okay, so you just divide 66 by the answer that we just had, and it comes out to be 210 to the nearest degree. So we've got our answer. So we know that's 210. So then, what was the area of the piece of metal that was removed? Well, if we think about what's been removed, so obviously this sector up here, and this angle here now, well, we know x is 210, so that makes that angle 150. So that sector that's been removed will be the fraction of the circle times then pi r squared, so times 3.14 times 18 squared. And that'll give you your answer. Okay. And you get that 423.9 centimeters squared.